Hi Spring fans! In this installment of Spring Tips, we're going to go ahead and look at the programmatic registration of beans feature, the functionality in the upcoming Spring 5 release. Now, Spring 5 isn't due to be released until summer of 2017, but there's a lot of really great potential here, and I want to encourage people to try the bits and kick the tires, so to speak. And in order to do so, we're going to take a walk down configuration lane and look at some of the options supported in Spring Framework up until now, and look at this new approach that's now available coming in Spring 5. So in order to do that, we need to use SpringBoot 2.0, which of course is in snapshots right now, because it will depend upon Spring 5. Now Spring 5 builds on Java 8, so it features a Java 8 baseline, right? As a result, we can do some very interesting things when we define and register our applications with Spring. So let's see what that looks like and see how it plays out. We'll start our example today with a very simple, basically empty Spring application. And what I'm going to do is I'm going to strip back Spring Boot. I'm going to just go back to low-level Spring Framework itself, and we'll take a look at some very basic, bean registration approaches, some of which you may be familiar with. Now, if you've ever used Spring before in the last 15 years, you know that there's support for using XML application configuration files, and I won't bother showing that. It certainly still works, it's still there, it's fine, but what I'm interested in focusing on are ways to register beans using Java code, right? That's the thrust of this particular Spring tip. So let's suppose we have an application here, right? We've got two beans. Let's call that BarService, and we've got another one called FooService. And let's suppose that FooService depends upon BarService. So we'll declare a collaborating object here as something that should be provided in the constructor. And we have several ways we can tell Spring about this application. Let's suppose that this is our configuration application, or configuration class rather. I'm going to annotate it as such with @configuration. And let's say that we're using just a regular application context. Okay, so ultimately in Spring we have the bean factory, but bean factories just contain beans. There are some primitives for making it easier for developers to work with application. In an application, there's something called an application context, which in turn works with bean factories. And the application context provides lifecycle management and so on. So that tends to be the lowest sort of entry point into the Spring framework these days, and most people are familiar with that. We're not going to use Spring Boot for now. We'll come back to that later. And indeed, if I left things like this, the result of this run method is an actual application context, right? So I can get back there. I can get back to familiar ground fairly easily. But let's just do it the sort of harder way, right? We're going to say annotation, or rather application context EC equals new annotation config application context, and what it's expecting is a configuration class, right? So I'm going to pass in a configuration class here, and that'll give us our first way of configuring beans. If you knew about XML, you know that XML provides a way to register beans in a single artifact in a single XML configuration file, and the bean definitions are central, so all definitions are in one place, and it's easy to sort of survey at a single glance how things are wired together. The Java configuration style gives you that same benefit, and it's also very explicit, right? We don't have to rely upon inferred relationships. Everything is wired explicitly. So I say FooService, return new FooService, and I am depending upon a BarService, so I can say BarService, return new BarService. Now, one of these beans has a dependency upon the other, so we can tell Spring to satisfy the dependency by injecting the BarService like that, or of course I can just call the method like that. Either way, the result is I have a FooService that has the right collaborating object, right? So we can. I tend to leave it like this. It's just very, very convenient, and if I need to copy and paste the definition, it's there. So that's explicit, right? Now let's test this code. I want to test that this is actually working as we expect, and that we have two beans. So let's go look at our test code here, and we'll call this the context configuration annotation. We'll tell it to use the config 101 application.class, and we're going to inject the application context, right? So here we go. And here we'll say assert dot not null. This dot application get context beans foo service dot class, right? So here assert, oh, wrong assert. Okay. There we are. There we go. So there's that. And similarly, we want to assert that the bar service is not null. So we have two beans. One should be dependent upon the other. And we want to confirm that they're both there as we expect, right? So bar service.class. And let's run this test like so. Everything seems all right. Let's prove the negative by saying that we want this to be null, right? Let's just make sure we're not getting some sort of fluke response. I suppose in this case it doesn't really matter, but it's always useful to make sure we're not imagining things. Okay, so we are running the right test. Everything's working. Assert not null. Very good. Now that means that as far as Spring is concerned, we have told it about these two beans and they are registered. Now this is a little tedious. I have to manage every single instance thusly. I can layer these together. I can have one configuration class that imports some other config.class, right? I can do that if I want, and I can compose high order configurations thusly, but still I want to be able to only do this kind of work if I need to. Why not let the framework do the work for me whenever possible? So for this we have component scanning, right? And component scanning says that instead of explicitly defining the beans, I want to let Spring imply the relationships of those beans for me by annotating these beans with @component and other such stereotype annotations. So this is a stereotype annotation. It's got a role in the framework itself, and Spring will use that stereotype annotation to determine that this is a component that should be managed, right? So let's revisit that test. There we go. So there's our application. Everything seems fine, right? So now we've done the we've taken off the extra code. We don't have to explicitly define it. The fact that these beans are beans lives with the component themselves, and you can mix and match, right? There's no reason you couldn't have a bar service like so. Return new bar service, and then remove the annotation here for the bar service here, right? So in this case, we should see the same result as well as expected. Now, these are pretty straightforward approaches to registering beans. We can go a little bit lower. Sometimes it's useful to be able to register beans based on some conditions or some sort of dynamic state. So one way to register a bean is to use the bean definition registry post processor contract, right? So I can say a public static class my bean drpp implements bean definition registry post processor, and this callback is just a bean. I'm going to register a bean here. It's just a bean of a certain type, but this callback gives me a chance to register objects dynamically, right? I'm actually going to register lower level types of the underlying mechanism, the underlying sort of runtime definitions that Spring uses is something called a bean definition. So when Spring gets all this input from, be it from bean definitions or Java configuration or component scanning or whatever, they all coalesce into a big bag of bean definitions, and we can actually work with that, right? So I've got a bean definition registry here, and I can register beans thusly, right? So I can say I want to register a foo service. I want to register a bar service. Let's say I want to just register the bean bar service, and it's going to expect a bean definition, and I can use the bean definition builder here. So I can say generic bean definition, passing in the class that I want to define, right? So BarService.class, and I can say give me the bean definition, and there we are. There's my bean definition, right? So let's see if that works. I'm going to go ahead and comment this out. So now we have no bar service explicitly defined anywhere, save for this bean definition registry post processor. What I'm doing is I'm tapping into the bean definition registry, which is a lower level type inside the Spring application context, and I'm registering a bean programmatically, giving it a bean ID, and giving it a bean definition. Now these bean definitions are not actual objects. They ultimately turn into reflection code, right? Code that's used to instantiate the definition and satisfy collaborating objects and so on. So there we go. We've registered the bean using the bean definition registry post processor just to prove that it doesn't work. Just to prove that we're not getting lucky here. I'll register a bean of the wrong type, and we'll see that things fall apart. So Spring is looking for that BarService, and it's gonna get that definition by creating a no argument, by calling the no argument constructor of the BarService here. Naturally, we can do more sophisticated kind of registration. So let's go ahead and comment out this annotation here, so that now we have to do both. We have to register both. We can say register bean definition foo service, and here we're going to say bean definition registry. Sorry, bean definition builder dot generic bean definition. I'm going to say foo service. And what I want to do is I want to say that this is a generic bean definition, and I want to provide a certain type, but I want also I may want to also override how this object is constructed. And so there's a new feature in Java in Spring 5, which is based on Java 8, that takes a supplier. So what I'm saying is this bean is of type fooService.class, but I want to define how this object should be instantiated, right? So here I have a callback interface using a Java 8 supplier, right? And this Java 8 supplier is going to give me the chance to factory or build my particular bean. So in this case, I can say new foo service, and then the question, of course, is how do I get the collaborating object? Well, this gets a little tricky, right? I need to downcast this bean definition registry into something that will give me the type I want. In this case, I want to say that this is a bean factory, right? So sorry, bean factory.cast, passing in the BDR. I want to get a collaborating object, in this case the BarService, by type, right? So I'm actually downcasting the bean factory, and then I'm using the bean factory to resolve the collaborating object. And if we run this, everything should still work. Now remember, this bean factory is going to this definition here is going to be evaluated only when Spring is trying to factory the foo service. So it's at the right point in time. There's not really any risk of early initialization problems, right? It's only going to call the supplier when it's ready to do that, and so you can ask the context for a collaborating object accordingly. Now, this is all very, very convenient, and in this way you have a callback interface. You have an opportunity here with this bean definition registry post processor to dynamically register a lot of different objects, and here you get kind of it's sort of Java-like. You're not dealing with, you're certainly dealing with the low-level bean definitions, and you're certainly aware of the fact that you're dealing with bean definitions and not proper initialized objects. But it's still very programmatic. You can unit test this, and it's very, very nice. Now, one thing I like about this, of course, is that it lends itself to lambdas. So that's actually really convenient, right? Look at that. And we can make this a static import, right? So we can say there's that, and when you look at that, now the code becomes much cleaner. This, of course, can be moved out of the lambda definitions, in which case you don't even really need that, right? The whole thing becomes a one-liner, really, which I think is quite nice. So there's that. That code is much simpler to work with. Now, this gets us to the programmatic bean definitions or registrations. Our application context here, let's just downcast it to that again. Now we can actually register beans dynamically, and this is one of the really nice use cases. This is pure object-oriented sort of fun, right? So I'm going to say register bean, and let's suppose for now that I comment out our bean definition registry post processor. So actually, before I run this code, let's comment that out and confirm that everything is broken. Okay, so everything's broken because I've commented out those two beans. The unit test is failing. What I want to do now is I want to register beans with the application context programmatically, right? Using the new generic, the new register bean function, the programmatic bean definition and registration functionality in Spring 5. Now, I could do that work on this application context instance itself, and that would work. But I want to make it so that the code gets run at the same time as my unit test, right? I want to be able to make sure that my unit test sees the changes. And remember, the unit test isn't going to run this main method. It's going to have its own context, and it's going to run its own instance. So we need to provide a application context initializer. So programmatic bean definition initializer, right? And this is going to implement application context initializer. And the initializer is going to work with subtypes of generic application context, the generic application context subtype here, right? So what we're going to do is we're going to tell Spring to call this method when the application starts up. And there's a few ways to do this, right? There's a few ways to do this. We can tell our application, when we run the application, we can say AC dot, rather we can say programmatic like this, and call initialize passing in AC, and that would certainly work, that's not a problem. But what we really want to do is to have this get run uniformly, whether we're doing an integration test or whether we're doing this. So I'm going to bring back SpringBoot. I'm going to bring back SpringBoot. These two annotations are superseded. This one annotation provides the same benefit, really. And then I'm going to use the Spring application .run, right? So run, passing in config 101.application.class, passing in the args. And this method here is actually syntax shortcut for new Spring application. And I'm going to add an initializer, right? So add initializers. This is one way I can do it, but this wouldn't be seen in my test. So what I really, really want is just to have a single place where I can define these initializers and have both the main code and the test code find it, and that's spring.factories, right? So if I create my own meta-inf directory here, meta-inf, create a new text file called spring.factories. And this is the same mechanism, the same service loader mechanism that you may be familiar with if you've ever defined your own auto configuration, right? So let's see, application context initializer equals, and we need to provide it a reference to our programmatic bean definition and initializer, right? So Spring, when it starts up, is going to call this method, and let's just confirm that it does that. So we'll say system.error.println hello initializer, right? Okay, there we go. Let's run the code. It'll still fail, of course, but we should see hello initializer in there. We need to restore our test as well. So our test is config, okay, and we can say spring boot test. And at this point, that's all we need. In fact, we don't even need that. Remove it. Okay, start again. There we go. You can see hello, whoops, hello initializer, right? So there it is. It's certainly starting up. Spring is seeing it in the unit test as well as in the main code. Now it's our job to register programmatically the beans that we care about. So there's this nice new API, again Java 8 centric, application.context, applicationcontext.registerBean, and we can tell it the type. In this case, we want to register a BarService.class. Same as before, that works just fine. But we also have this nice supplier-based mechanism, right? So fooService.class, and then we just say that we want to return a new foo service, and it's going to expect a BarService. Well, here, we could just use the application context and get the bean like so. So that would work, certainly. Let's try that, right? This is an example. Let's see if that works. Okay, tests are green. But we can actually make this even simpler. We can say BarService equals new BarService, fooService equals new fooService, passing in the BarService, and really the supplier for each of these could just return the pre-instantiated references. And now we don't even have to explicitly call into the application context if we don't want to for simple code, for simple components that don't need certain life cycles managed or satisfied before they're referenced, right? So here the foo service has a direct reference to the bar service before anything else in the Spring ecosystem and the Spring application context has had a chance to post-process it and satisfy any dependencies. But again, it does read a fair bit easier, and it has the benefit of looking like the code that you write in the unit test. You're mocking your libraries out, right? So let's see what that looks like now. There we go. So the application has been started. It's registering the beans dynamically. Now this mechanism is very powerful. Now we have the ability to, with one bean, with one object, with one class, based on conditions and whatever other dynamic state you have, register one or more objects. And here you've got actual live wire objects. These are not bean definitions. There's no concerns about introspecting runtime reflection metadata as opposed to the actual objects. You can actually just work with the object graph itself. And of course you can mix and match, right? There's no reason that I couldn't just comment this out and then have the foo service explicitly defined to get the bean from the application context, which of course provides the definition through some other mechanism, be it at component scanning or Java configuration or the bean definition registry post-processor. So with that, we've looked at a few different ways to register beans with the application context. We've looked at a few nice features in Java 8, specifically the support here for registering a bean definition using a supplier, and the support here in Spring 5 for using the register bean method, also using a supplier, right? So thanks very much for watching, and with that, we'll see you next time.